Welcome back. Today we're going to be studying 3.5 translations. A translation is a slide from one location to another along an array which we would call a vector. A translation turns things into something with the same sides and the same angles. So if I wanted to draw a vector that defines a translation, I go ahead and I pick any two corresponding points on the image and then the pre-image. And then I can draw an arrow that says take it from here to there. I could define that arrow by the location at the beginning or the end. I could define it by the direction and the magnitude, and there's one more way to define it we'll look at. Now, no matter which two corresponding points I pick, I want you to notice that all of the vectors of transformation are all parallel to each other, and they're all the same length. So if let's say this was 5, this would be a distance of 5, and this would be a distance of 5. Finding a vector is pretty straightforward. If I have a triangle being transformed from here to here, I can slide it along 4 horizontal, then 2 vertical. Or if I want to draw the direct vector, I draw it like so. The way that mathematically we write this is kind of like a point. X over y, a change of 4 in x over a change of 2 in y. And let's take a look at how this is done on the next page with number 2. If I wanted to translate each figure according to the instructions provided, I want to translate it 2 units down and 3 units left. So I can pick any point. I go 2 units down and 3 units left. Now I'm going to show you the arrows on the first one, but the rest of them I'm just going to count it out. 2 down, 3 left. 2 down, 3 left. 2 down, 3 left. And then using my handy dandy ruler, like so. I can draw the image of that translation. I'll leave number 2 for you to explore on your own. Now, what if I don't have a grid? What if I'm living in the analog? Well, let's take a look at example 2. Use your compass and straightedge to apply the translation, or T, of A to B to the segment P1 to P2. Now, use the steps of the exploratory challenge twice for this question, creating 2 lines parallel to AB, one through P and one through P1. So here, I have to take AB and kind of move it over to here. And I'm going to actually, let's see, do I have a pencil? I'm going to take my compass here, and I'm going to mark, just as a guess, where it's going to end up. And then I'm going to do the same down here. It's always a good idea to kind of try and visualize where your translation is going to end up looking. So I think my translation is going to end up looking roughly something like this. But I don't know that's the case. So before I commit to that, I'm going to erase it and I'm going to do it properly. I know that to translate P, I have to copy this distance parallel to this. So I'm going to go ahead and I'm going to extend this line, this vector, so that's easier to work with. And then I'm going to also extend the line segment, like so, making sure to go right along the segment. And what I'm going to try and do is I'm going to copy the angle right here. So let's call this angle A. And I'm going to copy it over here to create a parallel to AB. And then I'm going to repeat the same process down here to create another parallel. And then when I place those segments in the right points, I'll be able to slide my whole segment along. Now, let's try to do that. Let's see. I have to mark an arc on that angle. It doesn't really matter how large that angle is. That arc is, just that I'm consistent. And I'm going to repeat that same arc where I want to copy the angle at the top. Then I'm going to measure how wide the angle is with my compass, making sure to put the point and the pencil on one intersection. Then repeat that up here. There we go. That got me my intersection. And I am going to draw my parallel in. There's my parallel line. Now I know my segment is going to be sliding along this line. Similarly, I can repeat this process. I'm going to bring my compass in right here. And bring it along here. Measure again how wide open the angle is. Bring that down there. Mark my parallel. There we are. There we go. Just a little too high. Next thing I do is I measure the length of my vector. A vector, remember, is the arrow that tells us how far our translation is traveling. And we measure that distance along our parallels. So it's like I made a copy of the vector AB here and the vector AB here to create the new points for my new transformation, which I can connect together with my straight edge, like so. And there's my transformation. Do you notice how that makes a parallelogram? That's going to be really relevant for what we're about to do next. When we come into class tomorrow, use your compass and straight edge to translate the circle below with this radius by this vector. If you want to try ahead of time, that's fantastic. I'll see you in class. Have a wonderful rest of your day.